Next, we are going to look at number 70, and then we're going to use number 70 to help us with number 73. So, find the x and y intercepts of the graph to the right. So I know my x-axis is here. So my x-intercept is where the line touches this x-axis, which is this point right here. Now let's write it as a coordinate. We know x comes first, y comes second. So starting from the origin, on my x-axis, I went to the right, 1, 2, 3, 4, 5, 6. And to the right on the x-axis is positive. And we didn't go up at all. We didn't go down at all. So my y value is 0. So I made a little note here. When you have an x-intercept, the y value is going to be 0. Now let's look at the y-intercept, which is going to be on my y-axis. So starting from the origin, I went down 1, 2, 3, 4. So the coordinate of my y-intercept, knowing x comes first and y comes second, starting from the origin, I didn't move left and I didn't move right. So on the x-axis, we moved by 0, and then we went down by 4. So the y value for our coordinate is -4. And so I made a little note here. The y-intercept is going to always have an x value of 0. So now let's use that information to help us with number 73. Oh, it's already there. All right. So it says, what are the x-intercepts and y-intercepts? Let's start with the x-intercept. And what we know about the x-intercept is that the y value is always 0. So when I use my equation to find my x-intercept, I have 3x minus 4y equals -36. Well, if y is 0, what I'm going to do is just plug in that value of 0 right there into y. And when we plug in, we know we put it in parentheses. So we have 3x minus 4 times y is now 0 equals -36. Now, 4 times 0 is 0, because anything times 0 is 0. So this is gone, and we're left with 3x equals -36. I need to solve for x, so let's divide by 3 on both sides. So I get x is equal to -12. And to write our x-intercept as a coordinate, we know that the y value is always going to be 0, and the x value here is -12. So there is my x-intercept. Now let's use the same process for the y-intercept. Okay. So let me rewrite my equation. 3x minus 4y equals -36. And for the y-intercept, we know that the x value is always going to be 0. So I'm going to plug in 0 into x right there. And when we plug in, put it in parentheses. So we get 3 times 0 minus 4y equals -36. Now anything times 0 is 0, so this is 0, it's gone. And we're left with -4y equals -36. Divide by -4 on both sides, and we get y is equal to a +9. Now if we write that as a coordinate, we know that for the y-intercept, the x value is always 0, and we solve for our y-intercept of 9. So there's your y-intercept right there. And if you were in my class, we use something called the cover-up method, where if you're solving for x, you're going to cover up the y, and then you're left with 3x equals -36, and then you solve. And we said if you're solving for y, then cover up the x, and you're left with negative 4y equals negative 36, and then you solve. That method is where this comes from. It's the exact same thing. Plugging in 0 makes that x disappear or makes that y disappear. So that's the exact same thing that we learned right here in number 73. Now the next one that we are doing is number 79. Okay, now if you were in my class, we used a graphic organizer that looked like this. Okay, and so what I've done is kind of just copied and pasted this part that we need for graphing so that we can use that to help us. All right, so let's get started. If we're going to have a dashed line, we know that we're not going to have an equal to sign on our inequality. So it's going to be either less than or greater than. No equal to sign. Now if we're talking about a solid line, then we add an equal to sign underneath our inequality. So less than or equal to, greater than or equal to, or just the equal to sign. Now if we're shaded above, that means we have to be greater than. So if we're going to shade above, that's going to be either greater than or equal to. And if we're shaded below, we have to be less than. So it's going to be either less than or equal to. Now let's go ahead and graph our inequality. Normally we see equations as y equals mx plus b, where m is our slope and b is our y-intercept. The only difference between these two is the inequality sign and the equal sign, but we're still going to graph it the same way. So our b is our y-intercept, in this case is -1, so put a dot at -1 on your y-axis. And if we look at our slope is 2/3. Now we know that slope from a graph, what we say is rise over run, and in this case it's given to us as 2/3. So we're going to rise up by 2, and we always run to the right, and we're going to go right by 3. So up 2 right, 1, 2, 3, put a dot. Up 2 right, 1, 2, 3, put a dot. Up 2 right, 1, 2, 3, put a dot. And now let's graph the other part of the line. Down 2 left, 1, 2, 3, put a dot. Down 2 left, 1, 2, 3, put a dot. Down 2 left, 1, 2, 3, put a dot. Okay, so we have just graphed our line. Now what we need to do is figure out, is it going to be solid or dashed? And are we going to shade above or below? Now I see that I have a less than sign in my inequality. So if I look at my notes, less than is going to be a dashed line. So draw a dashed line through your points. Now we need to know if we're going to shade above or if we're going to shade below. And if we look here, we have less than, which means if we look here, we have less than and less. Oh, I put the wrong things right here. Let's fix this. Let's fix this part real quick. Let's fix that. To shade above is greater than or equal to. And to shade below is less than or equal to. So please make sure you fix that box, shade above, and fix the box, shade below. Now moving on. The symbol in our inequality is less than. So if I look here in my notes, I find less than under shade below. So I'm going to look at my line and I'm going to shade below the line. Okay? And that is how we graph an inequality. And please keep in mind that if you have every question on the review completed, an answer for every question, and your work is shown, you get to use your review on the final, as well as you get 10 bonus points added onto your final. And you can put whatever notes on there that you need to put. You can write this here, what we wrote under dash line, solid line, shade above, shade below. So let's move on to number 80. All right, looking at number 80. All right, what I notice about these two equations is that they are both in standard form. And standard form is ax plus by equals c. And another way to say that is both x and y are on the same side of the equal sign. And if I look at my equations, x and y are on the same side of the equal sign for the first one. And for the second one, x and y are on the same side of the equal sign. So they're both in standard form. And that tells me to use elimination, which is also called linear combination. So let's go ahead and do that. Now if I look at my y's, I notice I have a positive 4y and a negative 4y. Well, if I have positive 4y's and I take away 4y's, those are going to cancel. So those are gone, they have been eliminated. So draw your line underneath, put a plus sign. 3x plus 2x gives me 5x. Bring down your equal sign. 18 plus a negative 8 gives me 10. Now if I divide by 5 on both sides, I get that x is equal to 2. So I know that the x-coordinate where these two lines are going to meet is 2. Now let me go ahead and solve for y. So what you're going to do is you're going to choose either the top equation or bottom equation, and you are going to plug in. So I'm going to choose the top equation. 3x plus 4y equals 18. Now we found that our x value was 2, so then why not just plug in our x value of 2 into x? So this becomes 3, and x is now 2. Put it in parentheses. When you plug in, put it in parentheses. Bring down my plus 4y equals 18. 3 times 2 is 6, so 6 plus 4y equals 18. Now I need to subtract 6 from both sides, and I get 4y is equal to 18 minus 6, which is 12. And if I divide by 4 on both sides, I get y is equal to 3. So my solution is the point 2, 3. These two lines are going to cross at the point 2, 3 on a graph. So then let's look at number 81. Number 81. All right. If I compare 81 to number 80, on number 80 I had a positive 4y and a negative 4y that canceled to 0. But if I look here, I have a 5x and a positive 5x. That does not cancel to 0. I have a positive y and a positive 2y. That does not cancel to 0 because that gives me 3y's. So what we need to do is force something to cancel out. And so this is what we're going to do. I'm going to choose to eliminate the y's. And I noticed that on the bottom, I have positive 2y's. And to cancel a positive 2 to a 0, I need to take away 2. So what I'm going to do is multiply the entire top equation by negative 2. I'm going to multiply everything in that equation by negative 2. So let's rewrite this. Following the first arrow, negative 2 times 5 is negative 10x. Negative 2 times 1y is negative 2y. And negative 2 times 14 is negative 28. Now we did not touch the bottom equation, so let's just rewrite it. X plus 2y equals 10. Draw my line underneath, put a plus sign. Now notice that negative 2y and positive 2y cancel out to 0. So those are gone. They're eliminated. Now let's bring everything down. Negative 10x plus x gives me negative 9x. Bring down the equals. Negative 28 plus 10 gives me negative 18. So I'm going to divide by negative 9 on both sides. And I get that x is equal to a positive 2. So I know when these two lines cross on a graph, the x-coordinate of that point is going to be a positive 2. Now what I need to do is figure out what the y value is going to be. And when we do that, we're going to just plug our x value back into the x in one of our original equations. So you can choose either the top original equation or the bottom original equation. I'm going to choose the bottom. So let me just rewrite it. X plus 2y equals 10. And I'm going to take my x value of 2 and just plug it in for x. And when we plug in, put it in parentheses, so we get 2, bring down everything else, plus 2y equals 10. Then I need to subtract 2 from both sides. We get 2y is equal to 8. Divide by 2 on both sides, so we get y is equal to 4. So I know that my y value is 4, and there's my solution. These two lines will cross at the point 2, 4. That's not good. They will cross at the point 2, 4. Now moving on to number 82. All right. Now let's look back at the little organizer we used for number 79. And let me grab that for number 82. All right, and something got deleted, so let me put that back there. All right, we need to write the equation, write the inequality for this graph. Okay, so we know we're going to start with y, and I have a dashed line, so I know I'm looking here. It's either going to be less than or greater than, but I know it's also shaded below. So if it's a dashed line and it's shaded below, we are looking at the less than symbol. So we know y is going to be less than. Let's find our slope and our y-intercept. So to find the slope, let's choose two good points. Here's a good point, and another good point is right here at the corner of the boxes. So I have a rise of 1, 2, so 2 over my run of 1. And that the slope goes with x, so 2 over 1x. And my y-intercept, is right here at negative 1, 2, 3. So y is less than 2x minus 3. There's your inequality of this graph. Now let's look at number 83. Okay. What I notice about my two equations, or the two equations in my system, is that both equations are in y equals mx plus b form. Okay? Both equations are in y equals mx plus b form. And a fancy way of saying that is both equations are in slope intercept form. And if they're both in y equals mx plus b form, we can either graph it, but a shortcut is to use our table in the calculator. So let's go ahead and just use our calculator this time. All right, so let's go to our calculator and go to y equals. I'm going to type 3x minus 6 in y1 and negative 2x plus 9 in y2. So let's go to our table and let me grab a picture of that. All right, so number 83, what I notice is that, or what we know is that we know our solution is where y1 and y2 are the same. So if we look in our table, y1 and y2 are the same right here. Okay, so we know that our x value is going to be 3. Our x value is going to be 3. And our y value is going to be, in this case, 3 as well. It's not always going to be that way. So we have an x value of 3, and in this case, a y value of 3. Do not write the y1 and y2 twice. There's only one y value, and it's 3. And then we write the x value. So x is 3, and y is 3. Now for number 84, we need to find the solution to the system. Well, the solution is where the lines meet. It's their intersection, and their intersection is right here at the point, let's see, 1, 2, 3. Then we go up by 1, 2, 3, 3, 3. So this is 84 is actually the graph of 83. They cross at the point 3, 3. Moving on to number 85. Use the substitution method to solve the system. All right, I'm going to talk about it the way that I talked with my students about it in my classroom. So what we do is we can take a highlighter or we can circle with our pencil, whichever one. What I notice is that in my first equation, I have a y that's all by itself. Okay? So in the other equation, I'm going to highlight that same letter that was by itself, and that was the y. Now, I need to look at this equation. And this equation is going to give me what the substitute is for y. And that's going to go and take the place of y. So let's rewrite the second equation, substituting y for its substitute, negative x plus 6. So 2x, bring down your 2x, bring down your minus, bring down your 3. Now when we plug in, we put it in parentheses. And if I have a substitute, say in the classroom, I'm not in the classroom with the substitute. So the y is going to come out completely, and the substitute is going to come in its place. Bring down your equals, bring down your 22. Now let me distribute this negative 3 inside parentheses, because we know parentheses means to distribute. So we get 2x, negative 3 times negative 1x is a positive 3x. Negative 3 times positive 6 is a negative 18. And that's equal to 22. Now, on the left side, I see some x's. And because they're on the same side, I can just combine them. So 2x, positive 3x, that gives me, 2x's and 3x's give me 5x. And then let's bring down our minus 18, bring down our equals, bring down our 22. Now it's just a simple equation to solve. No harder than anything you've seen on your weekly homeworks. So let's add 18 to both sides. And we get 5x equals 40. Let me make sure, 22, 32 plus 8, 40, right. And so if we divide by 5 on both sides, we get x is equal to 8. So we know that when these two lines meet on a graph, the x value is going to be 8. Now let's find the y value. So if I look at my two equations, my two original equations, which one is telling me I'm going to give you what y equals? Well, that's the equation that says y equals. So let me rewrite that equation. Y equals negative x plus 6. And if we know what x is, we're just going to plug it in for x. When we plug in, put it in parentheses. So y equals negative. X is going to come out, and its replacement 8 is going to go in, plus 6. So if I distribute this negative inside the parentheses, we get y equals negative 8 plus 6, which is a negative 2. So my y value is negative 2. Now when these two lines meet on a graph, they'll meet at the intersection, or the point, or the solution, 8 comma negative 2. So there's my solution. And the very last one, number 86. So for number 86, it just asks us to write a system. Okay, so let's look at what we have. What I tell my students is to look at the totals that you have in the situation, and that'll help you write at least one of the equations. So I see a total here of 412.50. So I know a total is going to be 412.50. And in math, a total looks like equals. That's what everything is going to equal. So I'm going to write equals 412.50. And then I need to figure out what goes here. But first I need to define what x and y are. So I'm going to make x be the adult tickets, and y is going to be the student tickets. So let's think about this. 412.50 represents the total income from ticket sales. So what went into the ticket sales? Well, each adult ticket was $6, and I need to add that to each student ticket, which was $3.50. So $6 per adult ticket plus $3.50 per student ticket is going to equal a total of $412.50. So there's my first equation. We use 412.50, that's gone. We use 6 and we use 3.50, those are gone. We can't use them again. Now let's look at this second sentence. The number of student tickets sold was 25 more than the number of adult tickets. Now what I call this here in my classroom is tricky wording. And when we have tricky wording, what we're going to do is this. In this case, it's saying 25 more than. 25 more than means you're adding 25 to something. Okay? 25 is gone, we used it. 25 more than means we're adding 25 to something. Now what's tricky about it is, what are we adding 25 to? So in this situation, you're going to be adding 25 to the second person or the second thing in that sentence. So if I look here, the first thing or the first person is student and the second person is adult. So I'm going to add 25 to the second person, which is the adult. And adult is represented by X. So we're adding 25 to the adult tickets, and that's going to equal the number of student tickets, which is Y. And so there's our system all set up. And if you want the extra practice, which I suggest, I'll help you set up the substitution, and then you can solve it on your own. And how we know this is substitution is the first equation. Whoa. Well, one of our equations is in y equals mx plus b form. Here, see, y equals mx, and we know that there's really a 1 here, so mx plus b form. And the second equation is in standard form, where x and y are on the same side. So that tells me right there, those are the clues that tell me I'm going to use substitution. Okay, so let me help you set that up. Pulling out my highlighter, and we are going to work this the same way that we worked number 85, which was also substitution. So I look for the letter that's all by itself in one of the equations, nothing else on that side of the equal sign except for that one letter. And I notice that it's this y, so I'm going to highlight it or circle it. Now I'm going to highlight that same letter in the other equation. I'm going to highlight that same letter in the other equation, y. Okay? So what's going to happen is this y is going to be gone because it's going to be substituted. So that y is going to disappear and y's substitute is going to come in. I know in some other classes you talked about player 1 and player 2. So here's player 1. Player 1 gets injured. Here's player 2. So player 2 has to go in its place. Okay? So player 1 is going to leave the field and player 2 is going to come in its place. So let's go ahead and write that out. 6x plus 350. Now we get to the y, or player 1, and he's injured. So he's gone. And in parentheses, I need to put in his backup player. 1x plus 25. And that equals to 412.50. All right? And you can solve that on your own with the note of, when we see parentheses, we distribute. If you want those extra 10 bonus points on your final exam score, please complete your fall semester exam review. And you also get to use that review on your final if it's completed. Good luck, Langham Creek High School Algebra 1.